So this last activity, last new activity of the course really, is an attempt to deliver on that promise from last week, which was, if we know that a series converges, and that's what we spent all of last week doing, figuring out whether we can say a series converges or not. But if I know a series of real numbers converges, can we say to what number it converges? What does a series converge to? And now that we have this list of usual suspect Taylor series, we can actually do that in some cases. So let's suppose that last week, or on the last midterm, I gave you this series, let's call it S, the summation of -1 to the n over n factorial. So its first few terms are 1, minus 1, plus a half, minus a sixth, plus 1/24, and so on and so on. So first of all, how could you have told me, what test would you have applied last week to convince me that this series is convergent? What's the most efficient test? Yeah, I agree. Ratio test. What do you predict the ratio test would say about this series? What would the ratio be? 1 over n plus 1 probably. As n tends to infinity, that tends to... The ratio tends to 0. Ratio tends to 0. Therefore, because 0 is less than 1, ratio test will tell us this is a convergent series. Great. But then what I couldn't ask you on the test is, what does this converge to? What is the value? Every convergent series, by definition, has a limit which is a finite value. So what is the value? What number do we get if we take 1 and subtract 1 and add a half and subtract a sixth and add 1/24 and so on and so on, ad infinitum? What does this actually converge to?
It looks like it's getting smaller.
The terms are getting smaller and smaller, which they must for the series to converge. But if I want to know what the series, not the sequence, but the series, the sum, converges to, I need to know something more. Namely, what I'd like to do is I'd like to look in my list of usual suspect Maclaurin series and figure out if there is one of them that I can match up with the series that we're looking at by choosing a fortuitous value for x, match it up with one of our Maclaurin series, which then we can translate into a function which we otherwise know by name, a function like cosine or arctan or natural log or e to the x or something.
So it's like it matches e of x.
Right. So taking a look at this series, our denominator of n factorial here seems like it matches up with, a few of the series on the left, but the one it seems the closest related to is the series for e to the x. So what I would recommend doing then is, if that's your hunch, put that series side by side with the one that you're looking at. So e to the x, on the other hand, is the sum of x to the power n over n factorial, n starting at 0 and going to infinity, is equal to e to the x. And so then my only question is, what's the relationship here? What value does x take that can turn the series on the left into the series on the right? X equals -1. So, because whatever we do with the series, we can do with the function inside the interval of convergence, and the interval of convergence for this particular series is all real numbers, so we're okay with that. Replacing x by -1 in the series, which is what gives me exactly the series I'm looking for, but then that will converge to the value of our function, e to the -1. So in other words, when I add up all of these numbers, 1 minus 1 plus a half minus a sixth plus a 24th and so on, the sum of that series is 1 over e. Or e to the -1 if you like, whatever. So if we can match up our unknown series to one of our usual suspects, one of our Taylor or Maclaurin series, by choosing a particular value of x to make it happen, then that function that the series represents, evaluated at that value of x, is the limit of this series, provided the series converges.